Right, so this is the first recording I'm doing for 2021, and what I'm going to do is to use my iPad and record the screen on the PC. So basically I run a web server on my PC and screencast my screen on my iPad and grab the event using the web browser, and then I can record everything on my PC. So anyway, so we're going to do some region grading. So the first thing we need is some kind of image. So here is my image. It would be very simple image. We have some green pixels here, and some red pixels here. Right, so to make things easier, I also record the index of the pixels so that we all know which ones I'm talking about. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And we need our list here of visited pixels. So like this. And we have something here that we're going to call Q. Well, first thing first, we need a seed. So I'm going to place the seed here on pixel 6. And now I can start running this algorithm here. So we got the seed, we got the point list, so that's now having 1 pixel, pixel number 6, and an array for visited. Okay, so is the list empty? No, because we got the seed. So we remove the seed from the list and say that we visited that pixel. Now we look at the neighbors of that point, which are these ones. And for every pixel in around pixel 6, we look if they are similar. So is pixel 1 similar? So is green same as red? No. 2, is green the same as red? No. 3, is 3 the same as red? No. Is 5 same as red? Yes, so we add 5. 6, well, it's already visited, so we ignore it. 7 is the same, so we add it. 9 is the same, so we add it. 10 is green, 11 is green. Okay, so then we carry on. Is the Q empty? No, so there is 5. We remove 5 and we add 5 here. And we're going to process these again. So now we are centered around that pixel. And well, we're going to do the same. So we ignore the one in green, we ignore the one in red that are already visited, so 5 and 6, and we had pixel number 9. What I could have done in my pseudocode is probably say if the point is not in the list. So what I could do is add this. So so if not visited and neighbor is similar to point and neighbor not in point list, then we add it. Okay, so I added this and not in our point list. So that way I don't have 9 twice. Okay, so now we're ready to process 7. So 7 is here. We move 7, visit it. So we centered here. We ignore all the green. We already ignore the ones that are visited. We ignore the one that is already in the queue. So here we don't add anything. Right, so now we process the next pixel, which is pixel 9. So we add it to our list of visited. So we centered here now. Right, so ignore the one in green, the ones that are already visited. Okay, so we need to add the ones that are left, so 13 and 14. 13, 14. The list is not empty, so we process 13 now. 13 is visited, so we centered here. We ignore the green ones, we ignore the ones that are already visited, and we ignore the one that is already in the list, which is 14. Okay, the list is not empty because it's 14, we dequeue 14, it's visited, now we're centered here. So, well, we ignore the green, we ignore the ones that are already visited, and we add the last one here, so that's 15. We add 15 to our list. The list is not empty because we got 15, so we visit 15. Yeah, I made a mistake here, I should have added here. So we visit 15, so 15 is visited now, so we're going to add the neighbors of 15, there is no neighbors, so the queue is now empty, so we are done. And our green object was here. And you can see that now we have a binary mask where we ignored the object in green. We only have the one in red. I should be using red really. So that's the pixel in red. And the greens are gone. So now what we're going to do is to look at how to use that in practice. Let's say with our CT scan. So that's what we're going to do. But that's the end of this section on region green, pseudocode. Now we look at an example.